So tonight's notes, our focus is on isosceles and equilateral triangles. So I'm going to be highlighting a lot of stuff. Make sure if I highlight something, you write that in your notebook. All right, so isosceles and equilateral triangles. So let's take a look first at isosceles triangles. So first we're going to talk about parts of an isosceles triangle. So please draw this picture right here. And it's very important when you're drawing this picture that we're paying attention to things that are specific to an isosceles triangle, like these two dashes right here. And these are the two congruent sides called legs. Now the angle where these sides intersect is called the vertex angle. So that's going to be B. So it's where those two sides meet. So side AB and CB meet at the vertex angle B. The side opposite of the vertex angle is called the base. So the side opposite of the vertex angle is called the base. And when I say opposite, that means that if I'm looking at B, it's the side that is not creating the angle. So AB creates the angle B, CB creates that angle. The side opposite to that is AC. You could also kind of think like there's a an arrow kind of pointing across like that. Okay. And the angles alongside the base are called the base angles. So our base angles in this example would be 2 and 3. Those are our base angles. So those are some important parts of an isosceles triangle that we need to know when we're discussing these, because if I'm talking about the legs, it's those two congruent sides. If I'm talking about the vertex angle, it's where these sides intersect. And the base is opposite of the vertex angle. Okay. So this is super important. So of all the theorems we've been talking about, this is very important. It's called the isosceles triangle theorem, all right? And it basically says this: if two sides of a triangle are congruent, then the angles opposite those sides are congruent, okay? So let's say we're looking at our example. So I'm going to type this out. You can write this as well. So let's say, for example, we have this. So if AB is equal to BC, so I'm looking at our figure right here, then the measure of angle A is equal to the measure of angle C. All right. So again, what I'm talking about is if AB right here, AB, is congruent to BC, or the length are equal, then the measure of angle A is equal to the measure of angle C. Because if I'm talking about AB, let's look at this segment AB. I'm going to go over it with, let's go over it with purple. Let's say I have AB. And they're talking about the angle opposite to that. Opposite means across from. So across from AB is going to be C. Wow, this looks pretty terrible. Okay. All right, let's see what else we have. And then the converse of this theorem is also true. So the isosceles triangle theorem is a conditional statement. It's that if-then statement. And the converse is another theorem that we see. And converse just means it's opposite order. So instead of saying if the segments are equal, then their angles are equal, it's the opposite. So if two angles of a triangle are congruent, then the sides opposite of those angles are congruent. So the sides opposite of those angles are congruent. So let's see how that changes. So let's take this original statement and let's see how it changes. Well, a converse, you just switch the if-then. So instead of saying if A AB is equal to BC, we're going to start by saying if the measure of angle A is equal to the measure of angle C, then AB is equal to BC. So if the measure of angle A is equal to the measure of angle C, then AB is equal to BC. And I think that's all we got on this page. So please make sure you get all these notes. Definitely want you to draw this picture. So let's do some practice with this. So let's say I have a triangle, and I'm going to say this triangle is JKL. So JKL. Make this a little bit easier to see. Oopsies. And I'm going to tell you that JKL is an isosceles triangle, all right? And we are going to know that from this picture because I'm going to, where is it? I'm going to say this. So JK is congruent to KL, right? And I'm going to tell you that the measure of L is 68 degrees. And so we need to find the measure of angle J and the measure of angle K. All right, well, let's look at these congruent sides. So we have KL is congruent to KJ. So at this point, if I'm drawing this, please be writing this in your notes. So let's look at opposite from each other. So what is the line, or the angle, I'm sorry, what is the angle opposite from KL? Well, opposite, it's going to be J. And then KJ, the opposite angle, is 68. So remember that theorem we just talked about. If we know that segments are congruent, so we know that KL is equal to KJ, then their opposite angles are also congruent. So if KJ is opposite to 68, then KL will also be opposite to 68. So this angle J will also be 68 degrees. So that angle right there is also 68 degrees. So these two angles are congruent. And to find the measure of angle K, well, we're not necessarily saying that that's 68, but we learned today that the interior angles of a triangle sum to 180. So if I know that J is 68, L is 68, I don't know what K is, the measure of angle K, but I know together they all add to 180. We can use that to then solve for our missing angle. So go ahead and try that. I'll try it on my calculator as well. And hopefully I'll get the right answer. But you guys will definitely be able to check me when I don't. All right, we should have gotten that our measure is 44. 44 degrees. So that measure of angle K is 44 degrees. All right, let's try another one. So we have number 2, and my picture is going to look a little different than the first one, but it's still going to be an isosceles triangle, CDE. And I'm going to tell you it's isosceles, and these two sides are congruent, and this angle is 106 degrees. All right, so I have this side CD and this side DE are congruent, and let's look at the angles that are across from them. The angle that is across from DE, even though it might not look like it in the picture, is C, because C is the only angle, the only vertex that doesn't create DE. It's not a part of it. So, but we don't know what C is, okay? All right, and then CD, the opposite angle is E. Again, we don't know what that is, but we do know that they're congruent. So let's just call this X degrees right here. And then let's say that this right here is also X degrees, because if this is an isosceles triangle, the angles opposite of the congruent sides are also congruent. And right here we can set up an equation to solve for X. So we have X plus 106 is equal to 180. Do a little bit of algebra. 2x plus 106 is equal to 180.